In 2015, scientists observed gravitational waves. For the first time ever, we could actually see the distortion of space-time as it reacted to huge events in space, like the collision of black holes. This was one of the most exciting physics discoveries of our age, and the team involved were even awarded the Nobel Prize in Physics last year. So why is this discovery now being called into question? Okay, this is some pretty earth-shaking, heck, even space-shaking drama. Scientific tea, if you will. Some scientists are now questioning the methods used at the Laser Interferometer Gravitational Wave Observatory, which we all commonly know as LIGO, where gravitational waves were first observed. It's kind of like a really polite but really nitpicky episode of The Real Housewives of Astrophysics. Just so we're all clear, detecting gravitational waves is really freaking hard, which is one of the reasons why it was such a big deal. When black holes, for instance, collide with each other, they can merge, and in that merging process, some of the energy of that collision is released into the universe as gravitational radiation. This is essentially a ripple that distorts the Earth by about the width of an atomic nucleus. So you can see why it was pretty impressive when the LIGO scientific collaboration said they were able to detect this wave. But the minuteness of a gravitational wave is not the only problem LIGO faces. Yes, the detector does have to be unprecedentedly sensitive to observe and measure a gravitational wave, but it also has to be able to pick out that wave from the endless buzz of other background noise, like the natural vibration of the Earth itself. So in order to make sure that what they're measuring is really a gravitational wave and not something else, LIGO has two independent sites, one in Louisiana and one in Washington. Between these two detectors, almost a continent away from each other, there shouldn't be any overlap in their noise patterns. But the wave, the signal they're actually looking for, should show up in corresponding places at both observatories. So we should be able to easily identify what is noise, all that stuff that doesn't match up between detectors. Then when you subtract all that away, you're left with the signal, the gravitational wave. At least, that's the ideal. And this is where the friendly collegial discussion starts. A team of physicists at the Niels Bohr Institute in Copenhagen made their own analysis of the LIGO's freely and publicly available data, and they take some issue with some of the methods used. When the Danish team reanalyzed LIGO's data, they found that while the wave signal does match up between the two detectors, so does some of the noise, which it shouldn't, because the noise is supposed to be random and independent between two observatories, which introduces the problem that maybe the signals that LIGO picked out are less clear than the world would like to believe. As you can imagine, there's been a lot of back and forth about this. The LIGO team has responded to the Danish team's concerns by basically saying the methods and computer programs they used to extract the original data are extremely complicated and the Danish team wasn't using them correctly, which then prompts responses from some people like me who say, okay, but even if your science is right, it should at least be repeatable for other teams in your field, LIGO, you diva. And the Danish team responded by saying, thank you for teaching us more about your computer program. We redid our analysis, and we still think your results are kind of funky. And here's the thing. This kind of kerfuffle has happened before. Einstein predicted gravitational waves' existence in 1916, and if we've actually detected them, we've now observed his theory of general relativity in the tangible, physical properties of our universe, which helps us better understand gravity and where it comes from and why it behaves the way it does. Pretty huge and important mysteries we're still facing in physics. Since Einstein's original proposal, several other noteworthy experiments have tried to detect gravitational waves, with two standouts claiming that they had, to much excitement, only to then be debunked very publicly. It was rather embarrassing for all involved. So it's right to be skeptical, especially about something as huge and groundbreaking as this particular phenomenon. But when all is said and done, and when the dust settles around this flurry of agitated physicists, even in the most extreme scenario, scientists still all agree that we've definitely detected gravitational waves. This is the real deal this time. It's not that LIGO didn't detect the waves, it's simply that their analysis may need improvement. And if it remains unimproved, these methods could be introducing room for error that no one wants to have to deal with. This is the scientific process in action. As you watch this video, LIGO is putting together a detailed document revealing further how they got their results. So what could have been a potential rift has instead opened up some important dialogue in the scientific community and will hopefully be productive and just help us do the science better. And as of this early December, LIGO detected 4 more black hole mergers while looking through their previous observational data. The researchers say these detections weren't as loud and needed more careful analysis. So with that in mind, maybe this new paper could help quell any debates about their techniques. As dramatic as it sounds, I don't think it's going to provide enough material for an ultra-exciting Hollywood reimagining. At least, not yet. I guess we'll see what happens. What do you think about this science saga? Let the world know with your very own website. Domain.com is awesome, affordable, reliable, and has all the tools you need to build a new website. They can fulfill all your website needs. They offer .com and .net domain names and intuitive website builders. They have over 300 domain extensions to fit your needs, from .club to .space to .pizza. Take that first step in creating an identity online and visit domain.com. For more science drama, check out this video here and keep coming back to Seeker for more breaking science news. Thanks for watching.